Hello, everyone, and welcome to our session today. Today is our second session of our set of 5 webinars, which is entitled New Horizons Pathways for Women in Citizen Science. So, this is basically commemorating the International Day of Women and Girls in STEM. It started on the 11th of Feb and we'll continue till the 10th of March, for which we have 5 sessions. Today is the second session. And the basic purpose of these sessions is to introduce you to citizen science projects and how could you actually participate in these citizen science projects and share the excitement of astronomy. So today we have with us 3 guests. We have 2 very young ones. We have Amoli Kakkar, who's going to start and introduce to you all some citizen science projects, and then to be taken over by Khushi and Teja, both young astronomers, and they will tell us about their journey with citizen science projects in astronomy. So let me just introduce all 3 of them, and then they can one by one talk to you. So Amoli Kakkar is a homemaker who's now a very passionate amateur astronomer. She's an avid astrophotographer, has been featured in AVSO as an observer. She's taken part in several citizen science projects with discoveries to her credit. I think there's one which today also got added on, right, Amoli? Yeah, she's got one more today. And she trains students for the International Asteroid Search Campaign, of which is one of her students. So welcome, Amoli.
And thank you, ma'am.
Our second speaker today will be Khushi. Khushi is our space girl, young girl, 19 years old. She's a space enthusiast from her childhood and has started citizen science projects a few years back. She's discovered 139 supernovae, 49 preliminary asteroids, 2 provisional asteroids, and a lot of variable stars. She has been part of the Planet Hunters project, the Dark Energy Explorers, the ASASS Supernova project, the Disk Detective, Spectra Police, Gravity Spy, etc., other citizen science projects. She's a space educator teaching astronomy and space science. She's worked with many space-based companies. She's a social worker and a science communicator, spreading knowledge about astronomy. She's currently pursuing her bachelor's degree from Government College under Punjab University, Chandigarh. So welcome, Khushi.
I'm glad I'm here to talk to you.
We're also very excited to have you. Very excited to have you because you are one of the highlights, right? Young women in STEM, young girls in STEM. And our third guest today is Teja. Teja Begari is a young junior astronomer of India, recognized by India Book of Records as an ambassador for the AVSO, which is the variable stars group. And he's at present, he's just in school. He's doing his grade 10, but has a keen interest in astronomy. He's been recognized as a junior astronomer of India by the Indian Book of Records for the contribution to astronomy, popularization of citizen science projects, All India Radio invited speaker, awardee in Global Kids Achievers Award for the category of astronomy, silver honor in the International Astronomy and Astrophysics competition. So welcome all 3 of you all. It's really nice to have you all. And we are looking forward to our session. So we'll be having Amoli speak, and then Khushi and Teja. And after they finish there, we will have an open question and answer session where you can actually interact with them and get more details about what they've been working with. So let's start with Amoli.
Yeah, thank you, ma'am. And welcome all. Today, as Priya ma'am suggested, that we are going to talk about the citizen science project. Now, what actually are citizen science projects? As a layman, one would understand that it is something related to science, but it's not only science. It can include many other fields also. Like, see, when we are children, we all have that curiosity to learn and to know how the things happen. So we can conclude that the scientific analysis of data conducted with the help of common man or the common people, the citizens of any country, is called a citizen science project. Now, citizen science project has been given different names also. It is said as a community science or amateur science or crowdsourced science. So there are different names which people give to citizen science projects. Now, how do these citizen science projects actually help? The basic goal of the citizen science projects is to obtain some meaningful, useful data that aim to advance scientific understanding and which can be applied to the real world problems, like the global warming, like the vanishing of the trees, like the rise in the height of the, not the height, the level of oceans, the disappearance of different species. So we as citizen scientists can help our actual scientists to analyze the data which they collect, but they do not have enough time to go through all about that data. So we help them to analyze that data and then pass it on over to them so that they can go the next step. Now, there are about 4 main features of any citizen science project. The first and the foremost is that anyone can participate. There is no age limit. There is no foundation that you have to be a science background student or a science educator or anything like that. You could be a small kid, a small student, a college-going student, or a working professional. Like me, a housewife. I am a citizen scientist, and I am really proud to say that, because being a housewife, I am passionate about a few things, and doing citizen science projects helps me curb my interest. So the next point would be participants use the same kind of data so that they have actually the same set of rules to analyze a particular data in a particular project, any particular citizen science project, so that there is some kind of similarity in the results. Next is this data helps the scientist to come to the real conclusions, which would, if we as citizen science don't help them, it would take a really long time for them to analyze that particular data. And then a wide community of scientists and volunteers work together and share data to the public as well as the scientists. Now, the field in which these citizen science projects work are very diverse. As I said earlier, they can be of any type. They can be working on ecology or astronomy, medicine, computer science, psychology, engineering, genetics, anything. You think of it and you would have some kind of a citizen science project on the net, and you can connect with the particular organization to get enrolled in that particular citizen science project. Now, today we are going to talk about some basic, very basic platform of citizen science project, that is Zooniverse. I'll just make you go through it. I'll just share my screen. I hope it's visible to all.
Yes, we can see it. All fine.
Yeah. Now, this is the main screen of the Zooniverse projects. Wait. Not this one. Sorry. Yeah. This is the main screen of the Zooniverse platform. Now, what we need to do is, like, if I want to enroll myself in any of the project here, in any citizen science project, what I need to do is, first I need to log in. Now, for logging in, I have already made my account, so it's my name is highlighting here. Otherwise, here we have sign in option. First, you need to sign in. After making your account, you will get the permission to select any of the citizen science projects. Now, these are all the type of citizen science projects which are available on this Zooniverse platform. See, climate, history, language, nature, physics, social science, and space. So a wide variety of topics are included in citizen science projects. I think so. This caters to the interest of a large amount of population. Maybe people are having interest in literature. Some people are having interest in nature. So they can choose a project according to their choice and interest. As for me, I have been interested in astronomy, in space. So I mostly do the projects of space. Now, after registering myself, what I do is I just go to a particular project, and now I'll just explain you how you start with the project and what is the process which you follow in a particular kind of a project. Now, this is a very basic project called the Supernova Hunters. Right now, it doesn't have any data with itself, but still I can explain it to you how you can go about the process. I click on Get Started. Now, as you see here, there are 3 images. These images are written as finished. That means the data is no more available right now. What you need to know is that how do you analyze this particular data. So in every project, there is a tutorial. You need to go through the tutorial to get to know how you will analyze your data. You will have a step-by-step information given to you that how you will analyze the data. You can go through it as many times as you want, right? Okay. Now, after knowing that how you analyze the data, see, if I analyze and if I get confused at some particular point, because I am not a scientist, I am not a professional in this field, but I have interest. So what I do is, if I get stuck, now where to get help from? So here there is an option of field guide. This is a part where you will see there are different options given. Mostly, whatever project we are doing, the problem which we face will be showed up here and the solution will be there. Like this, like how to check whether it's a true supernova or not. So these are the different parameters. So I can go through each one of them before starting my project. So this is the way that we go about. And this process is same for each and every project on Zooniverse platform. Now, if I am done with the project for the day, I click for each and every image, I click on done. If I feel that my problem is not solved by using the field guide, now what to do? I click on done and talk. When I click on this, sorry, I have not this thing. Yeah. Now, when I click on this, I have a note, a space where I can write my problem and I can add my comment. After some time, what I will get is the Zooniverse people will get to know that I am facing this problem and I can get it resolved by them itself, right? But this takes time. But mostly what happens is all the problems are resolved by the field guide. So this is the whole process of how we analyze a particular data in a particular project. Now, if I talk about what do you gain by this? As for me, I gain satisfaction. As for me, I have achieved some certification. I have been awarded some certificates by doing some citizen science projects. So being a housewife, being a non-professional in the science field, I have got my cup of tea that, yes, I am doing something, I am contributing something to science. So this is what gives me satisfaction. And yes, sometimes you can be a part of a discovery. or you are given the credit of finding out some planet or some whatever project you are doing. Sometimes you are given that credit. So I think so we all as common people, as individuals, should take part in citizen science projects so that we can help our scientists analyze the data, which is really useful and which will be helpful for our children in future. I just rest my case here, and then I'll ask Khushi to continue from here. She'll be describing a few Zooniverse platform projects. So I just stopped sharing, and over to you, Khushi.
Yeah, thank you so much for giving me this wonderful opportunity to explain citizen science projects to you people. For me, citizen science projects give me empowerment, give me confidence, give me strength, as well as helping me in gaining knowledge of various subjects, as well as various topics of astronomy, astrophysics, and other subjects that are available on the Zooniverse platform. Most of the people confuse that, okay, I need a telescope or I need a computer and high professional laptop to continue these kind of citizen science projects, but not. The Zooniverse platform is available on your Android phone, and I'll be showing you how to use Zooniverse in the mobile phone. Zooniverse is providing you an application or mobile software. Whenever you are free, whenever you have something to do for the science, you can get over to Zooniverse and discover, as well as learn and grow and glow. Just a second, I'm sharing my screen and my video will be off just because I'm using my phone. I hope this will not matter, but yes. Just a second. Is this visible?
Yeah, we can see your phone screen. Yeah, we can see it.
Yes. So I have already logged into Zooniverse platform, and as Amoli ma'am has described how to log in, how to register. So I'm signing in, and here I'll go with just a second.
Khushi, could you just tell us which phone are you using?
It's Redmi Note 9.
Okay, well, how much RAM and all do you have on it?
64 GB RAM and 64 GB, yeah, that's 64.4, yes.
Okay, so you don't, so a phone of that kind will do, right?
Yeah, any phone can do. Okay, so I've already registered, and this is how it will looks like. And these are some kind of subjects, and I'll go to space as this is my field. And here you will get to know about, there are a lot of programs, and currently there are about 20 projects. Most recently, if you want to do most active, most helpful, help needed, most popular, and most recently updated. So these kind of projects, I'm explaining you one of the project named as Burst from the Space. So yes, so this is how it looks like. And then when you go through it, just look at this. It is 60% completed, and 2 people right now are working on it. And what you have to do is to join in and go to classify. And this is how the screen will look like.
What was the app you say? Play Store, because I'm trying to install it. What is the Play Store thing?
Zooniverse.
Oh, okay, thanks.
Yes. So the first thing that I want to say is looking at the sky with radio telescopes provide unique insight into a range of exciting exotic phenomena, from the stellar flares on nearby stars to exploding supernovas in a different galaxy. A radio transit can be varied as they're interesting. So let me give you some examples. For example, supernova and their remnants can glow in the radio and help us to understand the complex physics behind these cosmic explosions, as we all know. Some distant galaxies and their active center, which give us a clear and vision of formation and growth of supermassive black holes. And black holes is the topic we all are interested in. So these are there are two good ways of detecting the variability of potential radio transits, and we want to see which way work better for finding this exclusive bits. So as well as which method are well suited for screening out any non-interesting or non-astrophysical effects. So this is an image. So these are exactly what they sound like. Images of radio sources we see in our telescope images. And the above image is a light curve. And what is a light curve basically? So a light curve describes how the brightness of an object changes over time. So as we are interested in how we have to find variables or the transit in our radio sources, so these are the primary tool for finding new interesting objects. So in this project, both the light curves as well as the image will be shown to determine if the source is a radio variable or a transit. And one second, most of the people start asking this question that, okay, we have got these images, we have got this data set, but where it comes from? So it comes from a Meerkat telescope, and it is located in a Karao region of South Africa. What you have to do, as this is the image and this is the light curve, okay, and you have to find the radio source. First of all, you have to look for it. And one second, you are confused now. So go to tutorial and it will show you what are the steps of doing it. And then you go to continue. So these are the images which help you in determining the source. So what is source? The source is actually the bulgy point or the radio transit. You have to look for it. And the light curves determine the brightness, as I already told. Some are very noisy, some are very, having a clear-cut image. And this is how you have to solve the problem. For example, I just want people to please unmute your mic, because let's play this game. Play just like a game. Please unmute yourself when I ask something. Okay. So field guide is the thing. It will help you in solving these data sets. So first of all, let's look to stable sources. What are those? So stable sources tell us about the small level of variability. That means the uncertainties. The uncertainty is very low and the image will look like this. I hope it is visible. These are the light curves which are very smooth and very stable. So the radio source is stable. Okay, and when we go through extended blobs, it means these are the very blobby extended galaxies and the radio source is coming from them, and the image set will look like this. Please have a look and just remember in your mind for a minute. And these are artifacts. Artifacts are nothing but a background noise. When a telescope is capturing some images of the sky, some part of the sky has some glitches. Glitch means a fraction of a difficulty or a fraction of second in which the image got disrupted. And these are transit and variables. About variable stars and variables, Teja will explain you shortly, but the transit, they're looking like this, a curvy upslope or downslope light curves. Okay, and let's move to our game. Okay, this is our first data set and we have to identify which kind of source is this. So please identify which kind of object you are looking at from the options below. Is it stable, extended bob, artifact, transit? Or if you are unsure about it, you're confused. Okay, what is this? You're very unsure. So click on this. So unmute yourself and tell us which is this. What do you think? Is it stable, extended blob, or a noise or a transit?
I think so. It's stable.
Yeah, it's stable. So we have to just click on stable and done. That's it. And now we have one more data set in which this is the radio light curve and this is the image. And this, at this point of section, you will see there are only 2 points in the light curve, and it will represent unsure, because you are not sure about what exactly it is. It's not a noise, it's not stable, as well as it's not an extended block. So you have to done this.
Khushi, just a second.
And similarly, yes.
Khushi, could you go back to the previous image if possible?
No, I can't.
Okay, you can't. Okay.
And about this thing, this image set will just similar to previous ones, because the image is from a part of the sky, and this will show us an extended or bulb extended blob. As we see in the picture, here is a big ball shape image, and we have to just click on it and done. And what you will get, and when we click on the explore project column, we will get one thing that is about, this is the explanation of the project. If you are a student, if you are a working person, or else you are interested in space science and these kind of radio transits, you have to go for the research as well as the education part, because it will tell you more and more detail, as well as it gives you a bunch of knowledge which helps you in your studies, in your own career, as well as wherever and how much you're working on these fields. And this is the result part. And this is how the result part will show you on the screen. Sometimes you have been listed in the discovery list, as well as sometimes your name is being published in a journal where the discoveries have to be presented. Okay, let's move to one more project. Try this out. You have a lot of opportunities in this project. And when we go to the next project, I have some for you. And just a second. This is the space part where we are talking about. And let's move to dark energy explorers. And when it comes to dark energy and dark matter, our eyes are filled with intense brightness because we all know the space is made up of a lot of dark energy, about 75% of dark energy and dark matter. And scientists are continuously determining what exactly these are. So we all know that in between a galaxy, in the interstellar gases, the dark energy and dark matter is present, and we have to make sure that, okay, is this present or not? So we are helping our scientists with the help of a little contribution of around 10 to 20 minutes in a week, if you want to. It's 47% completed, and let's try to move it out. So this is dark energy project, and it's very simple, very, very, very simple, I guess, because you have to just identify which galaxy is distant or nearby. Let me explain you. As we know from the Big Bang, the universe has been started, and here we know that, okay, there is some part of the dark energy, and it is a very mysterious term the astronomers used to explain why the galaxies are expanding away from each other at an increasing rate. So our universe is expanding. So let's move it to the part. So these are the tutorial given to you to understand what is it is. And I'll explain you just a second. Okay, this is a task, whether this galaxy is a nearby or a distant. The basic principle used in this project, if a galaxy is near to us, that means it is visible very easily. There is no obstacle, there is no medium between it. Okay, medium, I'm referring to the dark energy part. Okay, and if a galaxy is far away from us, a distant one, or nothing, it will just look like a dot, a little dot, or just flatten away the images. Okay, so let's try to our first set. and it will show us an image in which a part of the sky has been captured by the telescope and it is provided to us. And here there is a small box from the bigger one. In the small box, you can see a black dark spot instead of a little roughly or a little point. So it is a very dark and visible to us. That means this is a nearby galaxy or a star. And you have to click on it and done. That's it. Isn't this easy? And when we go to this one, it will also show us beautiful black dots. That means it's also a nearby galaxy. Then done. And in this image, okay, this is also a nearby galaxy. Okay, Zuniverse, please show us some images which are a distant galaxy. And here we are. Okay, so this image is looking like this. In this small red box, you are saying nothing. Nothing in a sense. There is just roughy matter, not a dark black point. So that means it is a distant galaxy or nothing. And you have to done with it. And this is how you will continue the dark energy explorers. Dark energy explorers will definitely help you in understanding the part and parcel of dark energy, how the universe is expanding as the galaxies are moving far away from us. Each second, each time, it is just moving away from us. And let's move to our third project. There are a lot of projects, but I'm explaining the last one because then Teja have to explain you the wonderful concept of the variable stars as well as the AVSO. So let's move to one more project. I'll just name it. That is, just a second. It is named as, wait, I guess this is possible. Yeah, this is Witch Hunters. So this is Witch Hunters. Oh, one second. What exactly happened to my account? Okay, one second. This universe will also show you how many classifications you have done till now. What's showing? Yeah. As we all know, the gravitational waves, these are the ripples in the fabric of the space-time. So they are the cosmic messenger probing the dark universe. So it was predicted by Albert Einstein a century ago. So they are bringing new information on the most violent events in the cosmos, such as merging of the black holes or the neutron stars. So with glitch hunters, you will help the scientists to make gravitational wave detectors more sensitive and listen to the new source in the universe. As you will help scientists to study and reduce the noise in the gravitational detectors with the goal of improving their sensitivity and catching more and more part of the sky. So a particularly detrimental kind of noise is what is known as a transit noise. And this is particularly difficult to study, especially when it comes, when it appears for a very short period of the time. So they can last for a second, less than a second, and this is known as the glitches. So the first step is to remove them, is to understand their properties and to classify them according to the spectrograms. So let's start with this project. What you have to do is to join in, and you can see it is just 22% complete, and you have a lot of opportunities in just performing your masterpiece in this project. And just go through classify. And here we go. What you have to do, this is an image. Basically, it is the spectrogram showing to you. This is the red one. And when it comes to, just a second. Okay, this is shown in the blue one. These both are known as the auxiliary channels, and they contain the record of the signals made by the auxiliary sensors and controls that monitor the status of the day as well as the environment. Okay. So the presence of the glitch in the strain, so channels and the auxiliary strain channel and the auxiliary channel. The red one is known as the auxiliary channel and the blue one is known as the strain channel. What are they? You will just go through the about part and it will explain everything about it. Okay, let's start this. Do you see the similar shape in the red picture? That is the strain signal. Okay, I just sorry. I just mentioned it in opposite way as you do in the blue one. So you just have to see, okay, this or this are similar or not. So field guide is us for having a lot of information about it. It shows us how the advanced Virgo detector works, the Virgo channels, and what are those? So actually, I have gone through the project and find some kind of information about it. And they're saying, okay, the image set and the question, that is the task, will be approved very soon. So right now we have to just find, is it the same or not? We have a play button. You have to look like this. Okay, is this the same or something difficult or not? So unmute yourself and tell us, please. What do you think? Is it same or different? If it's same, go to the yes part and done. If you're confused, you need some help with this task part. Okay, let's move to the next. Is it the same or difficult? Different.
Looks very similar.
Okay, so let's move to the yes part. And if you're confused, you just go with this talk part. Let me show you in the next one. Okay, this is the next image. What do you think?
It's same again.
Are you sure it's same? Or if you're confused, we have something. Okay, is it the same glitch? This is the part that we help us. Okay, if it's same, then we go to yes and then done. And if you want to talk about the other people, okay, there are no comments yet. Okay, there is this picture or this data set is provided just for us right now. Nobody else has been determined this. So you just have a note, okay, this one is very difficult, or I can't determine it whether it is same or not. You just add your comment and see what people will reply you. And the people are the same person who are working on this project. So this is very interesting to learn more about the programs as well as the Zonever part. So I'm just stop my screen. Is my video visible?
Yes, we can all see it.
Yeah. So this is how you will explore the citizen science projects, and they are very easy to determine. Anyone from anywhere, you can do it. If you are free, if you are on a bus stand and you have nothing to do because your bus is late, you're waiting on your railway station, the train is late, you just open this Zooniverse platform and start. This is how I used to do whenever my bus is late. So these are the projects that will help you in each and every aspect. As Amoli ma'am has already mentioned, that this will also give you some kind of discoveries as well as certifications. And satisfaction is the most amazing thing one can get. And we are a part of the citizen science projects, and we know how much we are excited by solving each and every data set. Because whenever I just open Zooniverse, each time I used to go to similar project or a new one, and it works like a game. Right now, this era, students and the youth, they are just troubled themselves in the gaming, like PUBG, banned, I know. Free Fire, there are a lot of games. They just continue playing it. It will affect their minds as well as their mentality. But citizen science projects, they're just like games. We have all played right now. a 4 or 5 minutes of a day, it can help you in just refreshing yourself. If you are tired and just waiting, okay, my mood is just off, I want some peace, I want some thing to do in my free time, or if you have a fight with someone and you have to fresh your mood, just open Universe and start exploring the just citizen science projects. It's not in astronomy, but it is in various kind of subjects. So this is from my side. This is Khushi, and I invite Teja to so come out, speak for the people, and explain us what are the variable stars. These are very interesting topic, I guess. And what is AAVS? So what exactly it does? So Teja, please.
I think so, Priya ma'am. Khushi was a wonderful speaker, and the way she explained the projects was really good. I loved it, Khushi. Thank you so much.
Yeah, the excitement was really good, very contagious.
Yeah, the young age shows it all.
And that's exactly what we wanted. So now we have another young kid with us, Teja. And Teja, you can start sharing.
Thank you, ma'am.
We'll take questions in the end. Okay, so if there are questions which can't wait, you start writing it on chat. Otherwise, we'll take it once Teja finishes. Yeah, thanks.
Thank you, ma'am. And thank you very much, Didi, for a wonderful talk. It really helped me to understand about much more new projects on the universe. And now I would like to, I hope my screen is visible.
Yeah, it is.
Yes, all good. We can see it. Yeah.
All right. So, so today I would like to talk about the exploring the universe with the AAVSO. So talking about the AAVSO, AAVSO is an international non-profit organization working upon the variable stars, coordinating the variable star observations and reporting them to the AAVSO. So this is done for more than 110 years. It basically started in 1911 out of Harvard College Observatory for the then observatory director, Edward Pickering. And now I'm currently serving as an ambassador and a variable star observer at the AAVSO. So what exactly are these variable stars and why are we interested in them? And how can one observe variable stars and report them to the AAVSO? So I believe this is one of the interesting things you can do. It's just like the universe ones, but what you need to do is just to, go on a terrace and just observe them. So giving a little introduction about what variable stars are. So variable stars are those kind of stars whose brightness is changing within time, which means the variable stars are not really very constant. What I mean is there's a fluctuation in the magnitude. I want all of you to just look at this video. And here, let's talk about this particular star here. So this star's magnitude is very constant. There's no change in its magnitude at all. And whereas when you see the star just below it, there's a change in its magnitude. They're not, they're not twinkling. Twinkling is another different concept about the refraction and all, but it's not really twinkling. What this video exactly is, this is a picture of globular cluster taken on each and every day. And the picture is coming one after the other. So it's taken, let's say, for 4 to 5 days. And the picture is coming up one after the other. So they're not twinkling, but the same picture of a particular globular cluster. And it's coming one after the other. And you see that this particular star's brightness is not the same. So there's a change in its magnitude. Those kind of stars are called as variable stars. And why is it happening? There can be different reasons because we have different kinds of variable stars. Let's say one of my favorites are the eclipsing binaries. So in this case, there are two stars revolving around each other and there is an eclipse formed. But whenever we talk about eclipses, generally, let's say lunar eclipse, solar eclipse, we work upon or we deal with something called a shadow. But whereas coming to a star system, a two-star system, there's nothing to deal with the shadows, but the light of some other star covering the light of the primary star. So it's just like an eclipse, but there's the light of some other star coming in front of the primary star. That is how eclipsing binaries are. And let's say cataclysmic variables, which are a kind of binary stars, whereas one is the white dwarf and the other is a red dwarf, whereas the white dwarf is literally taking out all the material from the red dwarf, and there's uh, a jet kind of accretion form, and there's a variability, and we have pulsating variables which literally breathe in and breathe out. I mean, there's a disturbance in its core. There are many hypothetical theories as well on the pulsation theory of variable stars. So that is how there are different kinds of variable stars. So it's very important for us to uh, understand or think about them, or reporting them to the AVSO. So what do people do at the AVSO exactly? Before getting into that, you can also be a part of this, and you can also observe variable stars. You can also report them to the AVSO. What all you need? Anyone can be a variable star observer. All you need is unaided eyes, a pair of binoculars if you have, or a telescope. You don't really need to have a fancy telescope. You don't need to have a very big telescope, or you don't have to spend a lot of expenditure on buying a very fancy telescope. Without a telescope, a binoculars works as well. So if you are thinking of buying a telescope and not yet getting a telescope, or you just want to have a good pair of binoculars, binoculars help you to do variable stars as well, do the variable star observation as well, and some variable star charts to help you navigate where exactly they are. So you see the night sky, which is really beautiful, and you do not exactly know where exactly the variable star is. So you need the variable star charts. Some basic instructions of observing the variable stars, and a little patience is really very important when you observe variable stars, because you shouldn't expect a variability just the second day of your observation. So the first day you see some magnitude, and the second day you really cannot expect some a change in the magnitude. So you need a lot of patience to see the variable stars magnitude changing. So this is what you need to start up with variable star observation. So variable stars, finding variable stars, what you need is star charts. So very precisely, constellation stars. So constellations help you to understand, to locate a particular star or particular celestial object. So that's the only, I personally believe that's the only way how you use constellations. Else, talking in astronomy, that's how you use constellations. Let's say here we have the Orion constellation, and we have Betelgeuse, which is Alpha Orionis. So here, this is the Betelgeuse, and you have Rigel and different other stars. Betelgeuse is a variable star, which means there is a change in its magnitude. Whereas these stars you see, which are named 18, 21, 01, or 16, these stars are the constant, the comparison stars, which there is no change in their magnitude. So these stars which you see are the non-variables, and whereas the Alpha Orionis, the Betelgeuse, is the variable. How do you exactly know? Is before getting into that, let's understand something about alert notices. We have alert notices at the AVSO. There are stars of interest you can choose. So astronomers, whenever they're doing their, say, whenever they're doing their PhD, or whenever they're still continuing on their research, and they need, they really do not have a lot of time. You see, they're busy with their research and all. But then if they want to gain some data of the variable stars, they just send a notice to the AVSO. And that is where you get that onto the target tool, which I'll be showing in the next slide. So the target tool is where you can find the stars which are highlighted, and also the stars which are visible from your area. So whatever you report to the AVSO, that is actually purely used by the astrophysicists at the AVSO. So which is something really great and honored, because the data which you are giving is used by a typical professional scientist, which is maybe something that attracts you, because it's very important that your the data you get is used, and that's how it is used at the AVS. And target tools, selecting your own targets. 1 minute. Yeah. Oh, sorry. Yeah. So this is a target tool which helps you to get your targets. Say, this is more like campaign, but a campaign you can participate whenever you want. So let's say here, this is how the AAVS target tool looks like. So what does this target tool exactly tell you? So the target tool says you about the particular variable star and in which constellation it is, the minimum and maximum magnitude, and which kind of variable star that is. So everything will be given out by target. And whenever you see this last observed, so here it says 1 day ago, which is very less time, and that is the reason why it is green in color. And let's say here it is red in color, it's 7 months ago, which is a long time. And all this, see, these are the alerts. You see these kind of symbols, which means that they'll need to be given higher priority. And some of the other scientists want to learn or get data from the AVSO and the AVSO observers. And how do you start? So this is the important thing. How do you start observing variable stars? The first and most important tool, I believe, is the variable star plotting, which indeed is an important tool. So whenever you want to learn, you want to get a particular variable star and the comparison stars, you can just go here and plot a quick chart. And let's say I want to observe Alpha Orionis, which is also called as Betelgeuse, and you can just plot a chart, and you can still scroll down to magnitudes as well, but you can plot a chart. And let's say this is how you get the chart. So let's say this is SSCYG. So the middle one you see with the four, the four dashes on each of the pole. So you see this is a variable star, and the stars surrounding it with a number are the comparison stars, which are very constant, which means this is the brightness of the star, which is 98. It's not really 98 because you cannot really see a star with magnitude 98. Very, very, very faint. What exactly this is 9.8. And why do astronomers write that as 98? It's just because people might confuse, thinking the point as well as a star. So people might get confused that thinking the point as a star, and a lot of confusion taking place. So they write it as 98 or 109, which is 10.9, 103, which is 10.3, 86 is 8.8. So the lesser the number in the magnitude is, the brighter the star is. And the more the number in the magnitude is, the fainter the star is. So here the middle one you observe is the variable star. So the 10.9 is of course fainter. 8.6 is a bit brighter. So we know that, let's say on a particular day you observe the star to be fainter than 9.8, but brighter than 9.3. So you see, you observe that using this particular chart, and you use the comparison stars, and you see the variable star to be fainter than 9.8, but brighter than 10.3. So you can just draw a line like this with the numbers, and you can just do it very simply. So it's fainter than 9.8, which means its magnitude should increase. Fainter here means there should be the number should increase, and brighter, which means the number should decrease. So it's somewhere between 10.3 and 9.8. So let's say it's 10.2. That's how you report to the AVS. You don't really have to be very precise. Let's say 10.2569. So you don't have to be very precise. You can just report that to be 10.3, 10.2. So I know this is a bit just confusing looking at the first thing. So I'm taking an example here. So let's use common objects. There's a marble, there's a basketball, and there's a balloon. These are the three things we have taken. Here, the balloon is the variable star. The basketball is a comparison star whose brightness is constant, and marble as well is a comparison star whose brightness is constant. So now let's get into it. On day one, you have observed you see you just look at it. So on day one, this is like in between both of these. And in day two, it's exactly the size of a basketball. On day three, it's decreased, very much decreased. And on day four, it's much more decreased that you can, talking in astrophysics manner, you can barely see that. You see, it's very, very faint. So you can use this particular thing as comparison stars, the basketball and marble as comparison stars. Now, on day one, then I'm getting back to it with the actual calculations. So on day one, so we are quite sure that the comparison star's magnitude is going to be always the same. So here, because this is basketball, it's 10 inch and 1 inch, okay? And the balloon, which is around 50% size of this, all right? So now we don't have you. That's 50% size of 10, all right? So it's 5 inch, 5 inch. So that's how it is on day one. On day two, it's exactly the same size of the basketball. So it's 10 inch. So we already know the basketball's magnitude. Okay. So magnitude here, I mean, is the star, right? So here it is 10 inch and it's exactly the same size as basketball. So it's going to be 10 inch. On day three, it's around 40% of the complete basketball. So let's repeat 4 inch. On day four, you see its magnitude is twice the marble. So marble is 1 inch and you see it to be twice. So you have nothing to do with the basketball now because the stars, uh, you see, it's completely much more fainter. So you can use the marble. So the marble is 1 inch and you see it to be twice that of marble. So it's 2 inch. That is how you classify the magnitude and variable stars as well. So on day one, you see the variable star. So it's, let's say it's near to the comparison star. So you name it. It's 50% to the comparison star. You give it the 50% of the comparison star's magnitude. The 40%, you give it so. And if it's much, much more fainter, you have a star with a comparison star, which is also fainter. So that is how you basically understand about the different types of variable stars and how do you uh, calculate their variability. And how do you submit your observation? So I hope that's quite clear of how you can exactly observe them and how you can submit it. So you can submit your observation to the AVSO through WebOps. So you can submit it individually. That's what most of the observers do. But whenever you submit it, you just have to get logged in. And there's an observer code given to you. So let's say my observer code is TBEC. So there are observer codes given to particular individual. So you can submit your observations through WebOps. So you just click on this individual observations and it shows another page where you can just put out all the information, the name of the star, the date and time you have observed, the magnitude or the magnitude of the variables, magnitude of the comparison star you used. So everything is listed out and you should just fill them. And if you want to know much more about variable star, you can just go through the International Variable Star Index, the VSX, which is, I believe, the best star index you can get about variable stars. And there is also a light curve generator, which gives you out the, so there are, many observations made by many citizen scientists, many observers. And you can see here, the V here, let's say this is in green, the V, which means it's a visual observation. And you see it's in between 0 to 1 and 1 to 2. So that's all observed by the variable, the visual observers. So it's not the single person every time. This is a group of observations done by millions of observers. So here you see, it also gives out the latest observation. So it is by SSH. We do not know the person exactly, but that's his or her star group. So it's a light curve generator. So you can know the variable star magnitude of someone else. But you should never ever compare your magnitude with some other observers. Your observations are always the best. Your observations are always the best. You should never compare it with some other observation made. Let's say here it's 0.6. You're not going to do that. You're going to observe it from your particular area, your particular say uh, place where you live in, and that is how you submit your data. But you can just get a reference. You can just get a reference of the light, the magnitude through the light curve generator. And there is also a lot of educational material. You can obviously use them. So AVS believes that the sharing science can be done when we exchange our thoughts or teaching each other. So we have education material. So let's say you want to do a solar observation. So there's a solar observing guide. You want to do variable stars with the CCD. So that is there as well. And star observation, you can do that as well. So there are choice courses which are actually paid, but you get most of you get it from the manuals already. Manuals are easy to understand. And if you still did not understand through the manuals, or you still did not understand from my talk either, or from the educational material, you can get connected with a mentor. So you don't have to worry. I don't understand this, or how do I get into it? I might not be a part of it. There's nothing to worry. You can get a mentor. So AAVS also has a mentor program where the staff from the headquarters, the AAVS headquarters, which is in Massachusetts, will connect you with some of the other mentors throughout the world. So there are many mentors at the AAVS. So you'll be getting connected with some mentors. So that's in my beginning as well. And still now, I have my mentor, Mr. Robert Friedrich, who still helps me, explains me about how to get into this. So if there's any question, you can feel free to text a mentor. Out of my personal experience, I should really say that everyone at the AVS are very helpful, very kind, that you just give out your question, the reply is very fast, and they're very kind, I should say. So if you did not understand about very clearly, you can just text us at the aavso@aavso.org. So this particular is the mail ID of AAVSO. So you can just text, and there are friends at the AAVSO of mine who will definitely connect you with a mentor, and the mentor can help you get into the AAVSO variable star observation. With that, acknowledging all the women astrophysicists, all the women scientists who have been really helpful for me and to science in general. I would really thank all of them in acknowledging them. Thank you, everyone, and I hope this was helpful, and I hope you all have clear skies.
Thanks, Teja. Thank you so much. And now we'll open the floor for questions. If you have questions, you can unmute yourself, or you could write it on the chat. So please, viewers are encouraged to ask questions to any of the three speakers.
This recording will be available later?
Yeah, it's on YouTube. It's already on YouTube. And the link, it's on my same channel. I'll share the link.
Okay.
If you've registered, then I'll send you email again and you'll get the links. Okay.
Yeah.
So please register, then we can send. Yeah. Thomas, you have a question, right? You could please ask.
Yes, Teja, how can one contribute to the observation of variable stars just with the unaided eye?
Yeah, so it's quite simple. It's just the way explained. You can look at the stars just through your naked eye, and if you just don't want to even use a binoculars and you just want to do the basic observation, you can just go through the variable stars star chart, which gives you the comparison stars magnitude. And seeing the comparison stars magnitude, let's say, so let me just take an example. So just as explained that there are the basketball, the marble, and the balloon. So in one case, the basketball, so basketball is the comparison star, which the brightness is always the same. Whereas the balloons, the magnitude is changing. And how do you exactly know that? You know that by seeing the basketball. So the basketball is of 10 inch. and the balloon's magnitude, not really magnitude, but the size is, there's a decrease in the size, right? You know that because the basketball is still so, and there's a decrease in size. You on the first day you observe it, there is a change. The second day you observe it, there is something else. So you can do that through the variable star plotter. So you just get the magnitude of each and every comparison star, and you take let's say you take a printout of the comparison star and go out in the night sky, observe a particular variable star in the constellation, and then what you do is try to figure out the variable star's magnitude using the comparison stars. So using the comparison stars only, you can find out the magnitude of the variable star on that particular day. If you want to start with some of the easy variable stars, let's say algal, which is a binary star, so there's a variability in just 8 hours. Or if you want to go with one of the easiest variable star, Betelgeuse, which is in the constellation Orion, that can be done as well. So yeah, as explained,
Yeah,
all
but with the
Yeah.
unaided eye, I mean, is it possible to distinguish the brightness with just the naked eye?
You can, because let's say you see, let me give you an example. So you see Rigel, a variable, not a variable star, a star in the Orion constellation, and you see Sirius. So you obviously notice there is a change, right? Sirius is the brightest star in the night sky. And whereas coming to Rigel, it's not so bright. I mean, it's bright, but not so bright. But you see it just with an unaided eye. You don't really need a telescope. Or you see Betelgeuse, you see a change. So that is how you basically try to figure out, even with an unaided eye.
Okay, well, you have to have clear skies then and good eyes.
Yeah.
Okay.
Yeah. There's a similar, there's a related question by Casey. Do observations of variable stars, do we have to choose a high altitude place free from light, pollution, clouds, etc.?
No, you don't really have to do that. You can just do that from the area you live in. So there's also option while you're submitting your observation through Webbox. There's an option showing comments where you can comment whether there's a lot of light pollution. The star, there are a lot of clouds because of which you cannot see the star well. So there are options given to you in the Webbox, and the AAVS, so those who are actually getting the data will take that into consideration. So you don't really need to go to a high altitude place, or you don't really have to go to a forest to just make sure there's a clear skies. You can do that from place you live. So that works as well.
Yeah. And another question from Casey, is membership in AAVSO free?
Not really, but for India, people in India, there's a decrement. For developing countries, there's a decrement in the membership. If you want to get more into that, maybe you can text to my mail ID or also to the headquarters, aavso@aavso.org. There's a decrement for the developing countries in the membership.
And another one by Casey, instead of star charts, can we use apps like Stellarium or Sky Map? Are these maps reliable in showing the correct direction of stars?
The Stellarium or so will not really give you the exact magnitude. I mean, I'm not really very sure if Stellarium gives you out the magnitude. But if you think
you can click and get the magnitude. You can get the magnitude. If you click on it, it gives you the detailed magnitudes.
If it does, maybe then it's you can go with it. But I would suggest to go up with the variable star plotter of the AVSO because it's much more precise. And while you're submitting, also there's the variable star chart, code, so you can give out the code.
And I think for consistency, for it to be consistent, I think it's safer to do that more than anything, because there can be a variation, right? Depending on which source they got the magnitudes.
Yes.
So, how can we observe or differentiate variable stars with twinkling stars, which is due to atmospheric refraction? All of them are twinkling.
Yeah. So this is quite a nice question. So whenever you see a twinkling star, doesn't matter if it's twinkling or so. So let's say let's say Sirius is twinkling, and let's say Rigel is twinkling. So both the stars are twinkling. But Sirius is a way brighter than Rigel, and the twinkling of Sirius is also more, and the twinkling of Rigel is less. So the twinkling as well is a part of variability. So the twinkling as well shows you that the star is there's a change in its magnitude. So whenever you see two different stars and you try to compare them, even the twinkling gives it out, whether there's a change in its magnitude or there is no change in its magnitude or so.
Okay. Ammu, you have a question. You've raised your hand, so you can unmute and ask.
Hello.
Yeah.
Hello. Hi, Astro Legends. My name is Debsi. I'm an enthusiast on astrophysics, and I was searching about citizen scientists for past so many days, and this was really a positive platform for me. So first of all, thank you so much, guys, for this. My doubt is on a general basis. So can you give us some more information about how the citizen scientist observation help to the respective organization? Or in shorter, what is actually the connection with citizen scientists to those scientists out there? Or how these observations interpretation depicts to them?
I would like to take the question if anyone else would like to take, but let me give you a short thing because you described something about the organization. So people might think that what can a 8-inch, 10-inch or a binoculars do? But the professional telescopes used by professional scientists are a way far brighter to observe some specific celestial object, let's say variable stars in the case of the AVSO. So your observations help scientists to continue their research. So if there's a variable star discovery as well, there will be credits given to you from the headquarters of the AVSO, from the NASA, because NASA and AVSO are quite very closely connected. So the citizen scientist helps an organization to learn much more about it from their own personal research or from whatever they collect. It helps people to understand about what they work on. It gives them particularly much satisfaction, as said by our two speakers, Amoli ma'am and Khushi didi. So it gives much satisfaction for them because they're working upon something. So that is how I believe citizen scientists help an organization to get into the variables. Sorry, not exactly variable stars, but any kind of citizen science you do. So that's the connection between an organization and a citizen scientist.
Khushi, you want to add something?
Ma'am, I would like to add something.
Yeah.
Doing any citizen science project, actually it is a real-time data which is provided to you on the citizen science platform, and that particular data helps the scientist cover up that particular analysis which they would have taken a longer time to do that. So it saves time for them, and if you really do it correctly and sincerely, it really helps them to go about faster in their research work. So the discoveries or the predictions which can be made after the complete analysis of the citizen science project data is quite useful.
I would like to add that basically the problem is that there are so many objects in astronomy, and now there is so much data available in astronomy that the astronomy community, right, is not so large, not enough to actually check all this data. For example, what the next session we'll have would be on looking for asteroids. So if you have data where you're looking for these asteroids, the amount of professional astronomers are very little to actually look through all those images to look for those asteroids. And some of them could be important, interesting ones, if they're approaching the Earth or they're close or whatever, for whatever reason. But the amount of astronomers we have, professional astronomers, is very small in comparison to the data which is available today. And that is why the astronomy community, and not in all sciences do you need amateurs so badly, but in astronomy specifically, we need amateurs very badly because the amount of data is so much. And therefore, for example, if you're talking about variable stars or, like I said, asteroids, or looking for, the data from LIGO data, gravitational waves, you don't have so many people who can check all the data, with such thoroughness. So therefore, what we have to do is you involve citizens in them, and then you get a larger set of data, which is used for various purposes. Like there's Galaxy Zoo, where you classify the morphology of galaxies, because you don't have astronomers who are going to check through 1 million images of galaxies. while you can get citizen scientists to do that and this thing. So I think this is a very unique, science in which the contribution made by amateurs is very important even for professional scientists. Me being a professional scientist, I'm having these sessions because I want to encourage citizen science activity, because it is a very important component for professional astronomers. You have a variable, a star astronomer suddenly notices there's a certain star showing variability, and then you can actually go in to do some more detailed observations of that star to check why is it varying in a particular way. So I'd say in astronomy, this is a very important contribution to the science. It plays a very important role. Khushi, I see you want to say something. Bolo.
You have covered my part. That's okay. I want to say the same thing.
Yeah. So Thomas, you want to say something else?
Yes, maybe I can add something to that. I have studied computer science, and now I'm studying physics and astronomy. And I've also learned from my astronomy professor that it's very difficult to evaluate the images that we get automatically. So that is why people have to look at it.
That's right.
And not many tools that can do that. Yeah. And also I wanted to clarify, Teja, also for everybody else, because I'm probably important for them to know. You can be an observer in the with the VSO without being a member. Is that correct?
Yes,
yeah,
you can be
an
observer of the VSO without being a member.
Okay.
I am an observer without being a member.
So you can do it for free. That's what I wanted to clear.
We can do it. I am a solar observer. I am a sun observer. I observe the sunspots on a daily basis and then give my observations on a tabular form to the AVSO.
Mm-hmm.
Yeah.
Okay, thank you.
So do we have any more questions? Let me check the chat. Do any of our speakers want to say something, or anyway, we can always keep in touch. We'll have our next session. So I'm going to share.
Ma'am, excuse me, I have a doubt.
Yeah.
What is the source of data for the citizen science projects? Like, is it all the telescopes, the space telescopes, the ground telescopes, or
all of them? It's a whole set of this thing. For different projects, there are different telescopes being used, and it depends on which project you're talking about. So some are ground-based, some are space-based. It depends upon who's doing it. So you'll have everything.
And can we contribute data to these projects, like from our telescopes?
You can start your own citizen science project. For example, if you have something in which you would like people to actually look at things and do something, you can actually set up your own citizen science project. So for example, we have a project called Spectra Police, which is actually being done by a bunch of Indian students who are research scholars, and it's on spectroscopy. So they've actually started this thing. So if you actually look at my YouTube channel, in the earlier set of sessions, we already had a session on Spectra Police. You can have a look at that video, and that's a citizen science project which they have proposed. So you can propose one if you want, and yeah. So
okay, ma'am, thank you.
Welcome. Is there anybody else? So before we end, I would like to invite you for our next session. That will be on next Thursday, again the same time. And this one would be on the asteroid search campaign. Amoli will be with us again. We met Amoli today, and Dr. Mila Mitra. Two of them will be talking about the asteroid search campaign. This is a very interesting campaign. A lot of people have been working on it. You actually look for potential asteroids, confirm them, and get them named after you in case it's this thing. So that will be a very exciting session. So do join us next Thursday at the same time, and keep in touch. You have my mail. I've been sending mail to people who've registered, so you could check out this. Otherwise, the recording would be available on the YouTube channel. Priya, Hasan,
Priya ma'am?
Yeah. Khushi, yeah.
I'm sorry to interrupt, but can we have a group picture together? I request every member to please turn on their cameras so that we can have a memory of our session.
Sure. So I'll stop the share and let's have our session. Actually, I've always forgotten to do this because I'm so, this thing with other things that I don't do this. I'll have to take 2 shots because we have more people. But let everybody put on their cameras. Yeah, please, everyone. Arnav, put on your camera. Thomas, we had your camera earlier on. Yeah. Ammu and Arnav, put on your cameras. Ishani, Vanshika, Pratiksha, Kaushik, Roy, Subham Barik. Everyone, please. I still don't have all cameras on. Yeah. Okay.
I'm in my mobile, that's why.
Sorry? Okay, you can't. Okay.
I'm logged in twice, but I'm going away from mobile.
Okay, no problem. We have you on this
okay.
one. So I'll get you on this one. And yeah, so this is the first one. And here's the second one. And Rochelle, will we get your video? Ishani? Okay. Fine. So I'll send this to you all in the mail. And or people who have me on Facebook, I'll put it up on Facebook. Yeah. So see you, and let's meet next Thursday again for the asteroid search. Yes. Bye-bye.